Hi guys, in this video we'll understand what projectile is and we'll especially talk about ground to ground projectile. Okay, the stone is thrown from the ground and it reaches the ground. Okay, when a stone is thrown in air, its acceleration is g downwards, no matter in what direction or with what speed you have thrown it. We are neglecting air resistance here. Okay, so the acceleration will be g in downward direction, or we can say in y direction or downward y direction only. So a stone is thrown with a speed u at an angle theta. So what we'll do, we will take the components of u into mutually perpendicular directions, like this component will be called ux, will be u cos theta. So what is ux? U cos theta, and the component here in this direction will be u sin theta, that will be uy u sin theta, and the acceleration is this g downward. So it has no x component, ax is 0. This is very important thing, that no acceleration in x direction. Okay, and the consequence of that will be there will be no change in velocity in x direction, and acceleration in y direction is minus g, because we have taken upward as positive, downward as negative. Any vector which is in upward direction will be taken as positive and in downward direction will be taken as negative. That's why uy is taken as positive u sin theta. Okay, this is just a convention. Time of flight, maximum height and range. For time of flight, I'll simply say sy equal to 0. Okay, because it has gone up and comes down, so there is no displacement in y direction at all, or we can say overall displacement is 0. So just put sy equal to uyt plus half ayt square. We will get as 0. Uy is u sin theta, or just take it uy, I'll put the value afterward, g by 2 and uyt minus g by 2 t square. Just take one t common and you will get t as 2uy by g. Okay, it can also be termed as 2u sin theta by g. This is a very famous equation, should be remembered. Okay, t equal to, or time of flight, the capital T symbol should be used here. Capital T is equal to 2uy by g. It has no ux or ax. Okay, so time of flight simply depends on uy and ay only, because it is governed by a factor sy equal to 0. What is the height? H, maximum height can be called. For maximum height, obviously at the topmost point vy will be 0. Okay, so for maximum height we can say vy is equal to, maximum height is sy when vy equal to 0. Okay, so this is nothing but displacement in y direction when vy is 0. So vy square equal to uy square plus 2 ay sy. Just by solving this equation, 0 square is equal to uy square plus 2 minus g, which is the acceleration in y direction, and h. So h comes out to be uy square by 2g, which is u square sine square theta by 2g. And that is also a very famous expression, should be remembered. Okay, h also depends on uy only, or parameters in y direction only. What about the range? Range is nothing but displacement in x direction. This is called range. So range is nothing but displacement in x direction in time of flight. Okay, sx in time equal to capital T, this. So sx is very simple. Sx is uxt, as ax is not present. So uxt, t is 2uy by g. So sx or range is 2ux uy by g. Or we can say 2 u cos theta u sin theta by g, and just remember we can use 2 sin theta cos theta as sin 2 theta and u square, so it will come out to be u square sin 2 theta by g. Yes, time range depends on both ux as well as uy. Okay, one thing is to be noticed that the vector, the velocity vector, which is a resultant of x and y component, we can say x component is not changing its length, but y component is changing its length. Okay, at this point the only vector present is x, it is always ux, and at this point the ux will be same, and the similar vy1 will be here, just in upward direction. At this point we can say ux will be same, but there will be very small vy, let's say 2. Again at the same height I can say the same ux, but small vy2 in upward direction. So this is how velocity is changing. Ux remains same throughout the motion, but uy decreases, and velocity in y direction decreases, becomes 0 at the top, and then reverses direction and start increasing in magnitude. Okay, at this point again the angle is same theta, and it strikes back with the same speed u. Okay, to maximize time, theta should be obviously, uy should be maximum and uy will be maximum, and theta is pi by 2. Okay, so T max is nothing but 2 uy max by g. Uy max is simply u when it is thrown in upward direction. Again, to maximize height, we should maximize uy, so theta should be pi by 2, and h max is uy max square by 2g, so it will be u square by 2g is the maximum height possible. If a stone is thrown with a speed u and you are allowed to take any angle, then the maximum height will be u square by 2g when it is thrown at a pi by 2 angle. Okay, range, the expression for range is u square sin 2 theta by g. So this angle should be 90 degree, only then sine of that will be maximum. If this is 90, theta will be pi by 4 or 45 degree. So the maximum range, R max, is nothing but u square by g. Okay, so we can say maximum height is half of the maximum possible range. Okay, and one more interesting case is there, that if theta 1 and theta 2, if a stone is thrown with at different angles but with the same speed. Okay, it is thrown at different angles but with the same speed, so two angles which are complementary will have same range. Okay, so this theta 1 and theta 2, they are thrown with same speed, will have same range, and there is an angle or the stone is thrown if anywhere in between, the range will be larger than that. Okay, so it will come in this way. And there's one more question. Two stones are thrown, obviously they have same height, so we have to compare T1 T2. As height is same, as h1 is equal to h2, we can say uy1 square by 2g must be equal to uy2 square by 2g. As 2g is same, so we can say uy1 must be equal to uy2. As uy is same, we can say t1 must be equal to t2. Okay, so we can say if height are same, then the time period will be same, or time of flight will be same. If time of flight of two projectiles are same, ground to ground projectile I am talking about, so the maximum height will also be same. Okay, so these two parameters are same at the same situation. Okay, t1 equal to t2. What about theta 1, theta 2? Obviously from the diagram I can easily see that this is 1 theta 1 and this is theta 2, so theta 2 is greater than theta 1. What about uy1, uy2? They are equal, as I have already derived. Time is also equal. What about ux, uy? And I can say time is same, so r1 is greater than r2, as r1 is nothing but ux into t1, ux1 into t1, which is greater than ux2 into t2. So t1 and t2 are equal. I can say ux1 is greater than ux2, as uy are equal and ux1 is greater, so I can say u1 is greater than u2. Okay, so resolve all these questions. These are very, very important cases. You must know how to get the answers. Okay, enjoy.